Hello, welcome or welcome back. It's 27 January and as usual I'm doing leetcode. Uh, okay, what's uh, what's the agenda for today? Well, I have three problems before me. Just starting with the counting bits, and I can already sense the this video is boring. Okay, counting bits. It's an easy problem, so I'm not gonna spend so much time on this. Hopefully, given an integer and return an array answer of length n plus 1 such that for each uh, n for each I is the number of n set bits in the binary. Okay, got it. So we have n, so that means from 0 till n plus 1. From 0 till 2 we gotta check each number in this range and check how many set bits there are in its binary representation. So well, 0 is 0 in binary, so there is no set bit. 1 is 1, so 1 set bit. 2 is 1 0, so 1 set bit. And there is 4. Well, 3 has 2 set bits, 4 has only 1 set bit, and 5 has 2 set bits. And if you keep writing numbers like this, you will start to see there is a pattern here. The pattern is that if it's a even number, well, for recursion actually we can use these first two cases as our base cases. If number is 0, then there is no return 0. If number is 1, return 1. If it's an even number, now this is the body of the recursion. If this is an even number, then number of set bits is equal to, we're gonna run recursion on, well, it's a 4. If it's a 4, I've lost my train of thoughts. Let me show you some formula here. Well, if it's a 4, then 4 divided by 2 will basically will take the half of the number and run recursion on that, and like that we will get the answer. There's a very similar question like this. In that problem, we were only asked about we weren't asked to make an array. We were only asked for set bits for a given integer. So it's just little modified version of that problem, but we are not going to do it using recursion. We are going to do it using bit operations. Well, the most intuitive way I can think of solving this is this is 4, right? I can use right shift for this, like this. But right shift does is this is the sign, right shift y1, it will shift every byte, like it will shift every bit in this number to the over to the right. So one, something like this. If this is the one will come here, and this 0 will come here, and we'll have an additional 0 at the starting. And if I right shift it again, my this one will come to the end, at the end, right? And now I want to check, what I want to check is, after right shifting by 1, I want to check the last bit. For that I can use and it's something like and by 1 or 0. Yeah. Now what will it return? Last bit is not 1 in this number, so it returns just 1. Sorry, it returns 0. The whole number is 0. So I can just make a condition. Okay, let's just code it now. Let's call it helper. Okay, accept an integer, and I can say while n is greater than 0, because eventually my n will become 0, and we can keep this set bits 0, and I will return set bits. Right shift my number by 1, and then check number of set bits. Okay, so here I can just n plus 1 can run a simple loop while n plus plus okay, I will return this at the end. Alright, let's see. Okay, something is not right. Well, I think yes, let's submit. Okay, solution was submitted successfully. What is the time and space complexity? So for each number each number in this range, I am checking its I'm checking number of bits. So if my n multiply, I'll just write it here. Space time complexity, well, n into how many times does this loop run? It depends on the it depends on number of bits, number of set bits in the number, and that is also I think a variable. So if the number is for example really huge, something like 100, then there will be a lot of bits, set bits. So what is it? Should I just call it k? K being the number of bits in each n. Okay, we can verify it. For space complexity, space is we are only making use of this output array, so it's linear or constant because we're not really making space extra. We are not using any extra memory other than this output array. Complexity analyze n log n. Okay, wow. Okay. Let's see how is it log n. Explain time complexity of this. We loop from 0 to n for each number you call, which counts set bits by repeatedly shifting right. Yes, in the worst case, it runs once per bit. It runs once per bit of it. Okay, this is log n solution. So okay, I thought it's not really. I think it's the same as the recursion one in terms of complexity. Not really improved. Let's say a super improved version. index offset create an array initialize. Okay, so this thing can be done in linear time. Let's see how this is working. At ith index, right shifted bits count. Starting from 0. 0 right shifted to 1 is 0, it's 0. So this thing returns 0 and this thing returns 0. And okay, for next index 1, right shifted value, what is the right shifted value? Zero. So this returns item at 0th index, which is 0 plus I. Okay, we are adding the I. The number of set bits in a number depends on its right shifted value. Right shifting a number by 1 removes the last bit. The last bit itself is either 0. So instead of recalculating bits every time, like we are doing, We reuse the previously computed value. We reuse previously computed results. Initialize 0. 0 bit has no. Use the relation. Okay, but you're still. Okay, fine, good. This is a good solution. I learned that we could do it in linear time. Yes, cool. Next problem, daily temperatures. Spend 20 minutes on the last problem. This is a medium level. Given an array of integers, I tried this problem. Yeah, I did this I think in leetcode Sunday downtime video. Every Sunday I attempt new problems. Given an array of integer temperatures, represent the daily temperatures. Return an array answer such that at each index is the number of days you have to wait after ith day to get a warmer temperature. If there is no future day for which this is possible, temperatures. How many days we have to wait to get a warmer temperature, to get a number higher than 73? Well, there is 73, then the very next day. So we have to wait only one day. How many days we need to wait to get a number greater than 74? Only one day. How many days we'll wait to get a number greater than 74? 75, I mean. Well, the very next number is smaller. There is it. There it is. So 1, 2, 3, and 4. So we have to wait 4 days, and so on, and so forth. This is a monotonic stack problem. Yesterday I did next greater element, which is the problem you need to do before doing this one. If the temperature is say 70 today, then in future a warmer temperature must be either 71, 72. We could remember when all of them occur next. How can I use a monotonic stack in this problem? Because this problem really this problem really wants you to know monotonic stack. I'm going in. You should be so 73, 74. Let's define a stack first of all. Teacher stack, new stack, and for each number in temperatures, while, so this is the pattern. While stack is empty, this is for or. If stack is empty, or the element at the top, stack.peak, is smaller than my num, if element at the top is smaller than my num, or if stack is empty, only then we enter this loop, and we always push the number onto the stack. Now let's see. So this is my stack. 73 goes into my stack. 74 is greater than element at the top. So what we do here is I think I should probably use I index. I is 0 while I is smaller than top length I plus plus. So 73 gets pushed onto my stack. 74 is greater than 73. 0, 1, 2, 3, 4, 5, 6, and 7. So ith index is 1. Can I just well, we found a greater element, right? So how can I use this information to and I'm also thinking about $73. What is the index of 73? 0. Right. So, but at this point, index is 1. And I need 1. I need 1 in my output. This number doesn't actually have a use. So can I use a key value pair to $73, and whenever choose a sorted array. If array is non-empty, or and this when we found a creator element, then 73 at 74, which is who is greater than 74 at index 1. Zero, 1, 2, 0, 1, 0, 1, 2, 3, 4, 5, 6. So I probably make use of this hash map. Integer map new hash map. Map dot put stack dot pop and I let's inspect my hash map. Answer is new int pressure length